Good morning, everyone. In this video, we have talking about different type of two type of operating system, that is monolithic operating system, and the second one is microkernel operating system. From the block diagram, we'll try to understand. Okay, we have software and hardware part separated in the monolithic operating system. What we are talking about operating system is about the software. Okay, wait, I like on this. So I hope you can see now. This monolithic operating system, we have in the software part, the boxes are like app, application, that is full form of that is application, and we have scheduler and device driver. So oldest kind of operating system structure. Modern example are DOS, original that is Mac OS. Mac OS or DOS, that is nothing but your monolithic operating system. So till now we are using this OS uh, in our computer. Okay. The problem application can the problem like application can example thrash software software and thrash another application and hoard CPU time, abuse input output device, etc. Is the problem in this, and no good for fault containment or multi-user. Need a better solution for this monolithic operating system. Okay. uh, so in this type of monolithic operating system, we have only only thing is this is a oldest kind of OS structure. Okay, that is what we are using in the modern uh, sorry in the in the DOS. We are using this monolithic operating system. The problem of this monolithic operating system is uh, that trash OS system, OS software, like OS software will get thrashed and thrash another application and CPU time and abuse input output devices, etc. And it is not a good for multi-user, and so we need a better solution, and instead of this monolithic operating system. So the better solution for monolithic operating system is microkernel operating system. The microkernel operating system have uh, by block diagram we can see that it is there is four application, and application can directly communicate with server. In between there is a server, and there is one more server that is inside the software box. So if it is unprivileged server, that is privileged server and unprivileged server. This is a privileged server and unprivileged server. So it can communicate directly to the unprivileged server, or it can communicate to the privileged server. If it is communicating with the unprivileged server, then it has to pass to the privileged server, or it has to pass to the uh, device driver. Okay, to go to the kernel. Okay, inside the kernel we have a scheduler. So alternate structure, that is push some OS service into the server, and server may be privileged, that is operated in kernel mode. server is operated in the kernel mode. Increases both modularity and extensibility, and still access kernel via system calls, but need new way to access server, that is inter-process communication scheme. This is about your mm, microkernel and microkernel operating system and uh, monolithic operating system. So monolithic operating system is modernly we can call it as a DOS, and microkernel operating system, it still needs some improvement. There is both modularity and extensibility. Alternate structure is push some OS service into the server. Server may be privileged one. Um, so the next one is real-time system. So real-time system is used when there are rigid time requirement on the operation of processor or flow of data. Okay, when the operation of processor or flow of data, the rigid time, like a real-time system, is used when there is a rigid time requirement on the operation of processor or flow of data. Sensor bring data to the computer. The computer analyzes data and adjusts control to modify the sensor's input. Systems that control scientific experiments, medical imaging system, and some display system are real-time system. So, what is real-time system? Real-time system is used when there is a rigid time requirement on the operation of a processor or flow of data. Sensor bring data to the computer. The computer analyzes data and adjusts the control to modify the sensor input. System that control scientific experiments, medical imaging system, and some display systems are real-time systems. Okay. So the disadvantage of real-time systems are, first one is, a real-time system is considered to function correctly only if it returns the correct result within the time constraint. Within the time constraint, if it returns the correct result, then it is a real-time system. Okay. Secondary storage is limited or missing. Instead, data is usually stored in a short-term memory or ROM. The third one is advanced OS features are absent. Real-time system is of two types, such as hard real-time system and soft real-time system. So real-time system, it is what is that? Instantly it should give the output. So real-time system is used when there are rigid time requirement on the operation of a processor or flow of data. When rigid time requirement is required and rigid time requirement is there, at that time the real-time system is useful. Sensor bring data to the computer. So from the sensor we are taking the data to the computer. Computer analyzes the data and adjust adjust controls to modify the sensor input. The sensor input will be modified. The system that controls scientific experiments, like some of the like ECG monitor or like medical image systems, and some display systems are real-time system, means where there is you need a accurate output like scanner, uh, like now the electro automatic what is that, uh, yeah, what is it called, uh, X-ray machine. Yeah, these are now it is a real-time system because it is immediately taking the image from the sensor and bringing the data to the computer. From the computer, we are taking all the information. I mean, in the computer, it is analyzing the data and adjust the control to modify the sensor input. Okay, there is a disadvantage uh, of this real-time system. The disadvantage of real-time system are a real-time system is considered to function correctly if it returns the correct result within the time constraint. Like if that real-time system, if it is taking little more time to send the information, then it is that real-time system is not the proper one. Okay, and secondary storage for this real-time system is missing. There is no secondary storage in the real-time system. um, instead data is usually stored in short-term memory or ROM. In short-term memory or ROM, the data is stored. Okay, uh, the third one is the advanced ROM features are absent. The advanced ROM features are absent in this real-time system. Okay, sorry, advanced OS features are absent in the real-time system, because if we are going for advanced OS features, then depending on that OS features, like OS features need some process time. The process time, if you are using that much process time, then it is not a real time system, because it is taking more time to process that. Even if it is taking 1 millisecond, it is not a real time, because within a microsecond we need some sensor input. Within a microsecond data will change. So that is what like we are talking about. This is a disadvantage, because OS feature, the advanced OS feature, we cannot put into your real-time operating system. The next we have the real-time system in two different two types, such as hard real-time system and soft real-time system. Okay, so in a hard real-time system, uh, it guarantees that the critical task has completed on time. On time, the critical task has to be completed. Okay, means within that particular time it should complete that task. That is a hard real-time system. uh, Most of like aeroplanes, missile controls and all, we are using this hard real-time, I mean rocket, satellites, all this, we should use this hard real-time system. So it should within a microsecond it should respond and give the output. That is what the hard real-time system. It guarantees that critical task has been completed on time. The sudden task is uh, takes place at a sudden instant of time. At sudden instant of time, sudden task will be uh, executed. Okay, so that is the real time, hard real time system. The second one is soft real time system. It is uh, it is a less restrictive type of real time system, where the a critical task get priority over other tasks and retains that priority until it computes. These have more limited utility than hard real-time system. Missing an occasional deadlines is acceptable that is, as an example, QNX, VXWorks, and digital audio or multimedia in is included in this category. It is a special purpose OS in which there are rigid time requirement on the operation of processor. A real-time OS has well-defined fixed time constraint. Processing must be done within the time constraint or the system will fail. The real-time system is set to function correctly only if it returns the correct result within the time constraint. These systems are characterized by having time as a key factor. Now, both real-time system and hard real-time system and soft real-time system, in both it has to respond to the input. If from the sensor, it will take the input within a fraction of second. It has to respond to the input. That is what we call it as a hard real-time system. Within a minutes of second, within a second, we should respond to the input. Then it is called a soft real-time system. So both hard real-time system and soft real-time system, it has to respond to the it should respond immediately to the input. But in the hard real-time system, it should immediately respond, otherwise it is going to spoil the uh, like if something happens, if something if you are using this hard real-time system in our aeroplanes, if it is not responding immediately, then it goes like it is big problem for us, right? So but soft real time, like media system, if it is not working, it is okay, nothing will happen. So life is important. That is what uh, from this hard real time and soft real time we can understand. So next topic is task. Task is a piece of code or a program that is separate from another task and can be executed independently of the other task. Okay. In embedded system, the operating system has to deal with a limited number of tasks depending on the functionality to be implemented in the embedded system. Multiple tasks are multiple multiple tasks are not executed at same time. Instead, they are executed in pseudo parallel. That is, the task executed in turns as the task executed in turns as sorry as the use the processor. From multitasking point of view, executing multiple tasks is like a single book being read by multiple people at a time. Only one person can read it, and then it take turn to read it. Okay. Different bookmarks may be used to help a reader identify where to resume reading uh, next time. An operating system decides which task to execute in case there are multiple tasks to be executed. The operating system maintains information about every task and information about the state of each task. The information about task is recorded in uh, in a data structure called task context. when a task is executing, it uses the processor as the register available for all sort of processing. When a task leaves the processor from another task to execute, before it has finished its own, it should resume at a later time from where it stopped and not from the first instruction. This requires the information about the task with respect to the register of processor to be stored somewhere. This information is recorded in the task context. I'll repeat once again. Task is a piece of code or a program that is separate from another task and can be executed independently from other task. Task is a piece of code. I mean, it is small. I mean, one you can tell it is a subroutine, is a piece of code or a program that is separate from another task. From another task, it is separate and can be executed independently of other task. It can be executed independently, means separately you can execute that. In embedded system, the operating system has to deal with the limited number of tasks depending on the functionality to be implemented in the embedded system. Um, Task is a piece of code or a program that is separate from another task and can be executed independently of the other task. In embedded system, the operating system has to deal with a limited number of tasks depending on the functionality to be implemented in the embedded system. Multiple tasks are not executed at the same time. Instead, they are executed in pseudo parallel. That is, the task execute in turns as the use the processor. Like how, like consider there is one four subroutines are there. All that's different. You can tell, you can imagine, or you can think it is subroutines are called as a task. Okay, and it cannot execute parallelly, but it is executing for the processor, right? So from the multitasking point of view, executing multiple tasks is like single book being read by multiple people. So same book is read by multiple people. At a time only one person can read it and then take a turns to read it. Means one person is reading one page, the next page will be read by someone else. Okay, so different bookmarks may be used to help a reader identify where to resume reading the next time. The next person should come to know where the first person has first person has finished it. An operating system decides which task to execute in case there are multiple tasks to be executed. If there is a multiple task is there, then the operating system will decide which task has to be executed first. I mean, which have a higher priority. Consider it is a interrupt. There is more four interrupts are there, but which interrupt have a higher priority. So depending on that, operating system will decide which task to execute in case there are multiple tasks to be executed. The operating system maintains information about every task and information about the state of each task. Uh, so if the information about the task is recorded in a data structure called task context. So task context is the information about the task and the state of each task. What is the condition? What is the condition of what is the status of the task will be stored in the task context. When a task is executing, it uses the processor and the registers available for all sort of processing. For all sort of processing, what and all registers are required, it is using. So task is using it. When a task leaves the processor from another task to execute before it has finished its own, it should resume at a later time from where it stopped and not from first instruction. This requires the information about the task with respect to the register of the processor to be stored somewhere. This information is recorded in the task context. So, task context, just now I told, like, task context is keeping the information about the each task. Now, what is that information? What is that status of the task? The status of the task means when one task is executing. And when one task is executing, it will use all the registers. Consider the first task is to start executing the program from the beginning. Okay, so it will execute one four instruction. When it is executing four instruction, it is use some register. Now the second task to start from the fifth instruction. Okay, that is what reading the book means. It is completed one page, that is the one four instruction. The next page we should start from the next page reading should be started from the second task. Okay, so next instruction should be executed from the task 2, that is there in the uh, like that need the information about the registers. So all these register content and which instruction to be executed, that information will be there in the task context. Okay, next is task state. Now task state is in an operating system. There are always multiple tasks. Okay, at a time only one task can be executed. This means that there are other tasks which are waiting their turns to be executed. Like if one person is reading the book, second person want to read the same book. Okay, so it he has to wait for his turn, right? So uh, that waiting for his turn is called a waiting state. So depending upon the execution, a task may be classified into the three state, that is running state, ready state, and blocked state. So what is that running state, ready state, and block state? We'll see that. Okay. Uh, so running state, only one task can actually be using the processor at a given time. That task is said to be a running task, and its state is running state. No other task can be in that same state at the same time. Okay, other task cannot be in the same state in the same time. So next, second one is ready state. The ready state takes the that sorry tasks that are not uh, currently using the processor but are ready to run are in the ready state. There may be a queue of task in the ready state. Ready state means there is a queue of task which is ready to start executing. And third one is a waiting state. The waiting state task that are neither in running nor ready state but that are waiting for some event external to themselves uh, to occur the before it go for the execution on or in the waiting state. Before it goes for the execution, that is in the waiting state. The detailed the task state will discuss in the next video. Uh, but As I explained in the previous slide, that task, it multiple task, if it has to execute multiple tasks, it is like a reading book by, like 10 people are reading a one book. So if there is a 10 pages, one page will be read by one person. Okay, so that is what the way of task execute. So from one person, like the first person is reading the first page. After reading the first page, he will hand over to the second person. The second person is you reading the second page. Now, how he knows the second page is he has to read? He'll get the information from the task context. In the task context, he will get the information that the first task is completed reading the first page. So that is what the task execution. About task state, we'll discuss in the next video. I'll end up this video now, complete in the we'll continue in the next video. Thank you.